Hello students, in the previous class we had discussed about prime factorization and decimal expansion. Today in this class we shall discuss about HCF and LCM. Yes, everyone of you know about HCF and LCM very well, but in this class we will discuss some more facts related to HCF LCM and solve some problems on HCF LCM that most often come in your board exam, and at last we will see how to deal with the word problems related to HCF and LCM. So without wasting time, let's start the session. At first let me write the full forms of HCF and LCM. I know you all people know, still let me write again. HCF means highest common factor. Okay. So when we need to calculate HCF, we just need to find out the common factors of the given numbers or integers. Then we have to find out which common factor is the highest. That's the HCF. Next, LCM. LCM means lowest or least common multiple. So while calculating the LCM of two or more positive integers, what do we need to do? We just need to list the multiples of each number, then we have to find out the common multiples, and we have to take the least common multiple or the lowest of those common multiples, and that's the answer, or that's the LCM of those integers. Okay, so now let's see how to calculate LCM and HCF by using prime factorization method. Yes, about HCF we have discussed earlier in this chapter, that's in Euclid's division algorithm, how to find out HCF of larger numbers by using Euclid's division lemma. But here we will again discuss the basics, means how to find out HCF and LCM both by using the prime factorization method. So for that, let's take an example. Say the question given is find the HCF and LCM of 18 and 30 by using prime factorization method. Okay, the question would be like this: find the HCF and LCM of two or more numbers would be given by using prime factorization method. Okay, so let's see how to solve this. Okay, at first what do we need to do? As it is mentioned in the question, and we are discussing about finding HCF LCM by using prime factorization method, we need to find out the prime factorizations of the given integers. Okay, so let's do it. At first let's find out the prime factorization of 18. So let's factorize 18 by its prime factors. So 2 is a factor of 18, so 2 9 ja 18. Now 9 cannot be divisible by 2, so 9 is divisible by 3, so 3 3 ja 9. So we got 2 3 3 as the prime factors of 18. So we can write 2 into 3 square in place of 18. Similarly, let's find out the prime factorization of 30. So we need to factorize 30 again here. So it is divisible by 2, so 2, here it will be 15, then 3, 5 is 15. So now 5 is a prime number. So 30 can be written as 2 times 3 times 5. Okay, so the first step is complete. We have found out the prime factorization of 18 and 30. Now let's see how to find out HCF and LCM by using these two factorization. Okay, so to find out HCF, the rule is take, let me write the HCF. To find out HCF, you have to take the lowest power of the common factors. Means you have to take the common factors first, then you have to take the lowest of them. Okay, so see, in this example what you need to do, you have to first find out the common factor. See, here 2 is a factor, here 2 is also a factor, so we have to write 2. Next, here 3 is also a factor, here 3 is also a factor of 30, so you have to write 3. Next, here 5 is a factor of 30, but there is no 5 in the factorization of 18, so we will not write 5 because 5 is not a common factor. Next, what we need to do, we need to take the lowest one or the lower one. So here exponent of 2 is 1, here exponent 2 is 1, so both are same, so we need not worry about this, we just take 2 to the first power. Then here 3 to the first power and 3 to the second power. Here 1 is smaller than 2, so you have to take 3 to the first power. Okay, and the answer is 2 into 3, that is equal to 6. Next, let's see about LCM. So LCM rule is take the greater power, sorry, in case of 2 numbers we can write greater, but for more than 2 numbers you have to write greatest power of each factor. Okay, so here you don't worry about common factors. Okay, you have to take each of the factors from each of the numbers, then you have to take the greatest one. If there are common factors, then you have to take the greatest one. So let's see here, what are the factors? Here 2 and 3 are the factors of 18. Again 30 prime factorization contains 2, 3, so we don't need to write it again. Next 5 is another factor here, so we will need to write 5. Then you have to take the greatest. If there is common factor, then you have to take the greatest. Here 2 to the 1, 2 to the 1, so we will take 2 to the 1 power. Then 3 to the first power and 3 to the second power. Here 3 square or 3 to the second power is greater, so you have to take 3 square. Then here 5 to the first power, here there is no 5, means 5 to the 0 power is there, so you have to take the 5 to the first power. Now the answer is 2, 3 square is 9 and 5. So 2 9 ja 18, 5 ja 90. Okay, simple. Let me again repeat the steps. For HCF, at first you have to check for the common factors, then you have to take the smallest power of the common factors. And for LCM, you have to write all the factors only once. Okay, if it contains 2 3, it also contains 2 3, we don't need to write 2 3 again 2 3. We will write the factors once, then we have to take the greatest power if it is common in the given integers. Here 2 is common in both the integers, so we wrote 2 to the first power. Here 3 is also common in both the integers, 3 square and 3 to the first power, so we took 3 squared. Here 5, there was no 5, means 5 to the 0 power, and here it was once 5 multiplied, so 5 to the 1 is greater, so we took 5. Okay, so this type of questions most often come in your exam, so now you can solve this very easily. Okay, so let's see another sure shot questions that comes from this concept. So here what is given, the prime factorization of a and b is already given, that is a equal to x square y cubed and b is equal to x cube y z. So the prime factorization of a and b are given, and we have to find out the HCF and LCM. So let's find out. Okay, we need to find out these two. So how to find out? Here it is written, take the lowest power of the common factors. Okay, so at first for HCF we have to find out the common factors. Here you can see x is a factor of a, Here also x is a factor of b. So x is a common factor. We'll write x. Next, y cubed is present in the prime factorization of a. So y is a factor of a. X cube y z is the factorization of b. So y is also a factor of b. So we can write y also because y is common. Next, in the prime factorization of b there is z, but in the prime factorization of a there is no z. So z is not a common factor. So we will not write z in HCF. Then what we need to do? We need to take the lowest power. Here it is x square, here it is x cube. So between 2 and 3, 2 is smaller, so you have to take x square. Next, here it is y cube, here it is y only, means y to the first power. Here 1 is smaller than 3, so you have to take y to the 1 power or only y. Next, for LCM, we have to take the greatest power of each factor. Okay, so you have to write each of the factors, means here it is x and y common. So at first let's write them. Next, z is present in b, but z is not present in a. So we'll write z also because z is a factor of b. Next, we have to take the greatest one. Here 2, here it is 3. So 3 is greater than 2. So you have to take x to the third power or x cubed. Next, y cubed and y. Y cubed is greater than y. So we will take y cubed. Next, here it is z, but there is no z in the prime factorization of a. So you have to take z only. Okay. So this is HCF of AB x square y and LCM of AB x cubed y cubed z. Now I hope you would have understood this very clearly and you can solve this type of questions if it comes in your exam. So now let's move to the next fact related to HCF and LCM. The next fact is HCF is always a factor of LCM. Okay, so if you find out HCF and LCM of two numbers or more than two numbers, you will find that HCF of those numbers is always a factor of the LCM. Why? Because HCF is the factor of the given numbers and the given numbers are the factors of the LCM. So ultimately HCF becomes the factor of the LCM. Here also in this example you can verify this. You can see here 6 is the factor of 18 and 30. Means 6 is a factor of 18, also 6 is a factor of 30. Next, LCM of 18 and 30 is 90. Means 18 and 30, each of them is a factor of 90. So 6 is a factor of 18 and 18 is a factor of 90. So 6 is also a factor of 90. So this is a very easy concept. Now let's see how questions will come from this concept. So the question is, can 18 and 200 be the HCF and LCM of two positive integers respectively? Justify your answer. So you have to check whether it is not given what are the positive integers, but you have to say only, is there any possible numbers which have HCF as 18 and LCM as 200? How to check it? You have to apply this concept. As we know, HCF is always a factor of LCM, so you have to check whether 18 is a factor of 200 or not. If 18 is a factor of 200, then there are some possible integers which have 18 as HCF and 200 as LCM. Okay, so let's solve it. So how to check whether 18 is a factor of 200 or not? Simply we can divide 200 by 18. If there is no remainder, means 18 is a factor of 200. So let's divide 200 by 18. So first 18 1 ja 18. If we subtract 18 from 20, we will get 2 and we will step down this 0. Now 18 1 ja 18. Again we got 2 as the remainder. So it is clearly seen that 18 is not a factor of 200 as 2 is a remainder here. So now let's write it. 200 is equal to 18 into 11 plus 2. Here 2 is the remainder. So we'll write no 18 and 200 can never be HCF and LCM of two positive integers. Why? Because HCF is always a factor of LCM and here 18 is not a factor of 200. So you have to write because, as it is given to justify your answer, so you have to write the reason, because 18 is not a factor of 200. Got it? Now let's move to the next concept. The next concept is HCF multiplied by LCM is equal to product of both the numbers. It is very simple. It says if you find out HCF and LCM of two positive integers and you multiply those HCF and LCM that you found out, then you will get a number which is equal to the product of the given numbers. Means the numbers that were given in the question, if you multiply those two numbers, you will also get the same number that you got while multiplying the HCF and LCM together. Okay, so now let's see how questions can come from this concept and how will we deal with them by using this concept. The question would be like this: if HCF of 404 and 60 equal to 4, then find out LCM of 404 and 60. Okay, so two numbers are given and HCF is given, you have to find out the LCM. So let's write out the given part in the question first, then we will see how to solve this. So at first we will write the given numbers, let them be n1 404 and n2 be 60, that is number 1 and number 2. Then HCF is given, HCF is 4 and you have to find out the LCM. So how to find out? At first you have to write this relationship, that is HCF into LCM is equal to product of the numbers. So we'll write HCF multiplied by LCM is equal to product of next you have to put the values only. Here HCF is given 4, in place of HCF we will write 4, LCM is asked, so we will leave it like this. LCM, product of the numbers we have to multiply them, that is 404 multiplied by 60. Now you have to find out the LCM, so you have to transpose this 4 to the right side, and here it is multiplied, so when we will transpose a number which is multiplied on the left side, it will be divided on the right hand side, so it will become 404 multiplied by 60 divided by 4. Okay, now you have to solve this to find out the LCM. So let's solve it. So if we cancel 4 and 404, we will get 101 into 60. Next we have to multiply 101 by 60 to get the LCM. So LCM equal to 6 1 ja 6, 6 0 ja 0, 6 1 ja 6, there is another 0 on the right side, so the LCM becomes 6060. Okay, so this is very simple. You have to write this relationship, then you have to put the given three values, we will get the missing term. Here it is LCM asked. Sometimes what happens in the question, HCF is given, LCM is given, one of the number is given and the other number is asked. There also you have to put those three values that are given to you, then you will find out the missing value by solving simple equation. Okay, now we will solve some word problems and with that we will end our session. So here it is a word problem from NCERT textbook exercise 1.2 and the question number is 7. The question says there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field. Means in a field there is a circular path. Sorry, it doesn't become a circle. So let me make it a more likely a circle. Okay, so this is a circular path and Sonia takes 18 minutes to drive one round of the field. So this is the starting point and Sonia starts from here and she complete one round driving and she takes to complete this 18 minutes. Okay, Sonia takes 18 minutes to complete the round, while Robbie takes 12 minutes for the same. To do the same task, means to cover the same round, Robbie takes 12 minutes. He also starts from this and end here and he takes 12 minutes to do the same. Suppose they both start at the same point and at the same time. Say they start from this point and at the same time and go in the same direction. They also travel in the same direction. After how many minutes will they meet again at the starting point? So after how many minutes they will again meet here at this place? Yes, they will meet on the way many times, but at the starting point, after how many minutes they will meet again. So whenever questions comes like this, after how much time or after how many minutes will the same thing happen again, in that case you will always have to find out the LCM. If I will give you another instance, the question may come like this. There are two bells and one bell rings after each 5 minutes interval and the other bell rings at each 7 minutes. If they are wrong at the same time, after how many minutes or after how much time they will be wrong again. So in that case also you have to find out the LCM of 5 and 7, and the LCM of 5 and 7 is 35. So if they are wrong at the same time, after 35 minutes the same bells will be rung again. Okay, so now here also the same case is given. It is asked after how many minutes will they meet again at the starting point. Okay, so we have to find out the LCM. At first we will write the givens. You have to write time taken for Sonia to complete one round, equal to 18 minutes. Time taken for Ravi to complete one round, (12 minutes). Okay, next you have to find out the LCM. So let's find out LCM by prime factorization method. So we have to prime factorize 18. So 18's prime factorization will become 3 squared 9 times 2. Similarly you have to find out the prime factorization of 12. So it becomes 2 times 2, that is 2 square, which is equal to 4 times 3, 12. Okay, now you have to find out the LCM of 18 and 12. So what is the formula? Take the greatest power of each factor. So here there are only two prime factors of both the number, that is 18 and 12. The factors are 3 and 2, and you have to take the greatest power. So here 3 square, here it is only 3, so you have to write 3 square. Here it is 2 and here it is 2 square, so you have to write 2 square. So it becomes 3 squared equal to 9 times 2 squared equal to 4, so means 36. Okay, so after 36 minutes Sonia and Ravi will meet at the same point again. After 36 minutes Sonia would have covered 2 rounds and Ravi would have covered 3 rounds, and they will again meet at the same point. Okay, so hope you would have understood this question and how to solve this type of questions. Whenever you are asked after how many minutes will this happen again, so you have to find out the LCM. Okay.